So what Lacey did is she did a series dilution with hydrochloric acid, and over here, let me just turn this around, sodium hydroxide. This is 1 molar, that's approximately 1 molar. The acids turned out a lot better. So what she did is she took exactly 1 milliliter of 1 molar and put it in 9 milliliters of water. So we had 9 milliliters in every single test tube. So let's start at the acids, okay? We've got it, and I have right here a pH scale, color scale right here. With the acids, you can see with each dilution, especially here, from the reds over to the greens, you can see the change in the pH. Problem with the bases is if you go right, hold them up. For instance, this is the most concentrated and the least. This is 0.1 and this is 0.007. You can see too, it's kind of hard to see even with the pH scale, so you don't get the good differentiation. You do with the acids, you just don't with the bases. But we wanted to show you that, and the reason is, this is 1 molar. When you put 1 milliliter in with 9, it's now 0.1 molar. 0.1 molar is the same as 10 to the negative 1, which, if you could just put it up here, I'll show you here. So here's what she did. Let's just look at the acid side. That came out really well. This is her 1 molar, and this is called stock solution. She had 1 molar stock solution of the acid. She took 1 milliliter out exactly, mixed it with 9 milliliters of water. It's now a 10-fold dilution, okay? So it's now 0.1 molar. That's the same as 10 to the negative 1 molar. And when you do, remember pH is the negative log of the concentration of the hydrogen, okay, which is 1 times 10 to the negative 1. Because 10 to the negative 1 is the same as 1 times 10 to the negative 1. When you do negative log, 1 times 10 to the negative 1, you get 1. This is 100 point, this is 0.01. This is 0.001, and et cetera, et cetera. So this is 10 to the negative 1, 10 to the negative 2, negative 3, negative 4, etc. And this is the pH. So the whole purpose of doing this series dilution is to show you the relationship between concentration and pH. And as you can see over here, we can see it really distinctly with the acids. And if you get closer, we can't see it nearly as well, sadly, with the bases as we can with the acids. But the whole point is to show you the relationship between concentration and pH. And that's it.